Hi everyone, I'm Letian. In this video, I will explain 2020 Negeri Sembilan Addmath question 2. So this question, the 2a asks us to prove 2 tangent x to this equation. So to prove this kind of trigonometric equation, right, normally we need to refer to the formula sheet and find out what is the relevant formula we should use. So first we notice that there's a tangent 2x over here. And from the formula sheet, it's clear that this equation number 8, it also have a tangent 2a. So definitely we will need to use this equation. And then we also notice that inside of this tangent 2a equation, right, is 1 minus tangent square a. But in the question, it is 2 minus secant square x, which means we also need another formula that consists of secant square, which is equation number 4. So it's clear that if we are able to apply these two formula, we'll be able to prove this equation. Okay, so let's get started. From the left hand side, the 2 tangent x, 2 minus secant square x. First, we apply the equation number 4. Equation number 4 is for secant square x. So 2 minus secant square x, substitute in this formula, 1 plus tangent square x. So we have used the first formula, we'll get 2 tangent x, 2 minus 1, 1 minus tangent square x. Okay, so now notice now our equation over here is already very similar to what we have in the formula number 8. So what we need to do is just apply formula number 8. We'll get tangent to x shown. So we have proved that the equation is the left hand side is equal to the right hand side. Okay, let us move on to part B. So part B asks us to sketch the graph of y equal to tangent 2x minus 1. And very important is between the range x between 0 and pi, not 0 and 2 pi. Pi is also 180 degrees. So it's only the half of our usual range. And in order to sketch the graph of y equal to tangent 2x minus 1, right, you can use a step-by-step approach. We start with the most simple y equal to tangent x. And let's say we start with the range 0 and 2 pi. Notice this is just a regular tangent graph. Okay, and then the next step, we change the range of this graph. 0x, 0 to pi. It's still the equation y equal to tangent x. So basically what we do is actually, we just take the range between 0 and pi. It's at 0 and pi. Then we'll get this graph. But it's still not the end yet. What we want is tangent 2x minus 1, right? So this from tangent x come tangent 2x. When we add a 2 inside, it means to sort of multiply the equation, multiply the graph by 2 times. Notice in the graph here, if before this is just one set of line, right? And then for y equal to tangent 2x, the line pattern is repeated 2 times. It's repeated 2 times. So this y equal to tangent 2x for the range x between 0 and pi. And then the next thing is we can add a minus 1 to the equation, tangent 2x minus 1. What minus 1 did to the equation is a bit like shifting the graph. It's a bit like shifting the graph downwards. Notice that previously this part of the graph is at the y equal to 0, right? It's y equal to 0. This one is y equal to -1. So when we minus 1, notice that this part of the graph is shifted to y equal to -1. So we already got our answer here for y equal to tangent 2x minus 1. And very important, the range is between 0 and pi. This is our answer. Now we can move on to the next part. The next part tells us that using the same axis, it asks us to sketch a straight line to find the number of the solution for the equation 3x over pi plus 2 tangent x over 2 minus secant square x equal to 2. Again, for the range 0 and pi. Okay, so let us write down this equation. Equation is 3x over pi plus 2 tangent x over 2 minus secant square x. So notice that this particular equation looks very familiar to what we have proven in the previous part. So let us go back. It's actually this guy, right? What we have over here, which means we have proven in the previous part that this is actually equal to tangent 2x. So we can write down 3x over pi plus tangent 2x is equal to this guy. Equal to 2. Now, we want to sketch a straight line, right? So what we already have in this graph is y equal to tangent 2x minus 1. So we want to make a tangent, this tangent 2x become tangent 2x minus 1. So how do we make that happen? This one, we can minus 1 on both sides. Become 3x over pi plus tangent 2x minus 1 equal to 2 minus 1. And then again, we can move this into the opposite side. We'll get tangent 2x minus 1 equal to 1 minus 3x over pi. Okay, so now we get tangent 2x minus 1. This one is from here, tangent 2x minus 1. And also we have another part, 1 minus 3x over pi. These are the line that we want to add to our graph. So write down two equations. y1 equal to tangent 2x minus 1. This is what we already have in the graph. And then we have another y2 equal to 1 minus 3x over pi. We want to add this line into our graph, and then we want to find the intersection point between the two. The intersection point between these two would be, the number of intersection point between these two would be our number of solution. Okay, so to plot a graph, we need to find points, right? So here we can set when x is equal to 0, y would be equal to 1 minus 3, 0, pi equal to 1. So the first point of that equation is 0, 1. And then we can also set x is equal to pi. Why pi? because our graph, the range is between 0 and pi, right? So x equal to pi, y will be equal to 1 minus 3 pi over pi, we get -2. So the second point is pi -2. This is the 2 points we need in order to plot the equation. So we paste down the point over here. We need to add 2 points, 0, 1. The first is 0 and 1. Here is 0, 1. And then the second one, pi -2. Where's pi -2? Here. Here is pi -2. And then we draw a line to join these 2 points. Okay, so now we got our second line. Then we can find the number of solutions, which is the number of intersection points. This is the first, the second one, the third one. So we have 1, 2, 3, 3 solutions. So we can write number of solution is equal to 3.